I will introduce now openMINDS, where I'm the product owner and the lead developer, but there are a couple of people involved here that are surrounded in the CodeJam. So openMINDS stands for Open Metadata Initiative for Neuroscience Data Structures, and this is an umbrella for interlinked metadata models that build the architecture of neuroscience graph databases, where you then can share your data and research, such as, for example, in the EBRAINS knowledge graph, which Oliver Schmidt will present a bit later. Now, as a quick technical summary, so for me or for us, a metadata model consists of a defined set of linked metadata schemas. And each schema defines a set of related metadata that needs to be captured for describing different aspects of neuroscience research products. And for this, a schema specifies then key value pairs that are expected metadata properties, as well as the number and type of respectively expected metadata values. So as research products, openMINDS currently supports data sets, meaning data from human, animal, or simulation studies, computational models, software tools, metadata or data models, such as openMINDS or BITS, for example, as well as then brain atlases. Now, to describe these research products, we have integrated metadata models, and these are the following. So we have openMINDS Core, which covers the description of the general origin and the resource location and content type of research products. We have openMINDS Sans, which can be used to describe the anatomical location of neuroscience data, or to identify then reference brain atlases, coordinate spaces according to respective ontology models. And we have openMINDS control terms, which are attributes for terms of specific terminology, so that they are really well defined and reusable across research products. And then in addition, we currently have in development in-depth metadata models for computation, so covering the description of provenance for simulations, data analysis, and visualizations. openMINDS EFIS for the provenance of descriptions for electrophysiological experiments, and there are more to come. And ideas from the outside are always welcome for other extensions. Now, these distributed sets of metadata models, we want to have a united access points to them. And we have an integration pipeline that builds a central openMINDS GitHub repository, which also maintains vocabulary used across all these models and provides schemas in well-formal and well-known formats such as JSON schema. So next, I would like to briefly explain a bit more what the openMINDS pipeline is doing in the background and why we introduced the openMINDS syntax to define our schemas instead of using directly formal schema formats such as JSON schema or Shekel. And as you can immediately see from the displayed code for the reduced person schema, the openMINDS syntax outsources most technical attributes and general definitions, making the schema much easier to read, especially then for untrained eyes. Behind the scenes now, the openMINDS integration pipeline flexibly translates these syntax to any formal schema format. At the moment, we currently only support JSON schema. Shekel would be one of the candidates to come in future. And also our metadata instances, as they are presented in the knowledge graph, are validated then against these JSON schemas. So further advantages of that setup are that we can actually introduce additional technical attributes which are either cumbersome or unknown to formal schema formats. And we can define and maintain overall used vocabulary centrally instead of having to do this respectively in the distributed submodules. Now, in order to easily maintain the openMINDS vocabulary, it is automatically built within with each commit to one of the integrated metadata models, and then can be manually enriched over time with additional information such as general description and human readable labels. Of course, these manual enrichments are not overwritten but kept over time, and then automatically built and always updated are the vocabulary names and the information on where and when the schema type or property is used. Another plus is that we can centrally define references to other metadata initiatives, for example, schema.org. Before I come to tooling and support, I'd like to briefly present how openMINDS conform metadata are stored and provide you a glimpse on the power and flexibility of the architecture of such a graph database. And Ollie will demonstrate this a bit more powerfully later. But here is an outline of the schema model's core, control terms, and sense. And you see how these different schemas, which are the bubbles, are possibly linked via various connections. Now, depending on how much information is available or is supposed to be shared, the specific metadata model for a use case can then be less or more complex. Now, each metadata instance is, in our case, a JSON LD, for which a conceptual file is shown here. So we have in these files always a context value that defines the namespace. Here, of course, it's openMINDS, the openMINDS vocab. For the non-technical properties of the JSON LD. And we have the add type value, which defines the schema type against which the instance would be validated. And then we have the add ID value that contains a unique identifier that can specifically use to reference that specific JSON LD. And then depending on schema respective property value pairs, they can then be listed below. So our most simple one is our contact information, which currently only requires an email as a property, and I depicted here me as an example, which then can be linked via the add instance to a person instance, which then contains, for example, the given name and family name. For tooling and support, we of course do not expect that you write these JSON LDs on your own. You can of course do this, but to make your life a bit easier, we provide tooling and support around openMINDS. And before I come to this, I just want to also point out that we actually have an instance library already for select schemas, for example, for all the control terms, for the content types, meaning file formats, the licenses, and then various brain atlas instances. That you can find on our GitHubs as well. And then the tooling, so Stefan will give right after my talk the presentation on the openMINDS Python library, so I'm not going to go into detail here. This is for programmatic usage. And then we have the openMINDS wizard as a general user interface. So both tools can be used to generate locally your own openMINDS metadata collection formatted then as JSON LDs. Note though that both of these tools are released as an alpha version. So our end goal for both of these tools are that they are simple but highly robust so that other tools can build on it. Fairgraph and Zebra would be one of the candidates, for example, that are building on top of the Python library. So for documentation, we have our HTML views deployed as GitHub pages, which allow you to interactively discover the integrated metadata models with the respective schemas. And you will also find the list for the instances we provide for the selected schemas on here. Then we have a full human readable documentation on the EBRAINS Collaboratory. This is a work in progress, so feedback is always welcome. And then we have our question and discussion board, so a community forum on the INCF Neurostars, and our own support email. If you want to contribute directly, you can, of course, always participate in the discussions on our GitHub issues and make pull requests. This is highly welcome. Yeah, so we are supported by HPP, or we are powered by HPP and eBrains, but we are looking for external contributors to be closer to the whole community. And if you want to know more and want to discuss with us and so on, feel free to always get in touch, also during the hackathon. And as final information, I just want to point out that we want to become a general standard for graph databases or for neuroscience graph databases. And this is why we're not only adopted by the eBRAINS Knowledge Graph at the moment, but also by the Virtual Brain we are supported, and by the Japan Brain Minds project. And there are some others that are currently in discussion of adopting openMINDS. The other thing I want to point out is that, sorry for this, I forgot to turn that off. The other thing I want to point out is, now I lost my thought. Let's wrap it up here. I'm at the end of my talk. Thank you.